Size, weight, power, cost. Every engineer worries about these issues in their electronic systems, but nobody worries about it like defense industry engineers. They even have an acronym for it, SWaP-C, because, defense folks have AFI, or an acronym for everything. So when you're working on your MIL standard 461, 1275, or 704 compliant military commercial off-the-shelf base system, and you need a DC to DC converter module and a filter module that can supply reliable power that meets your SWaP-C specs, well then, you've come to the right place. Hi, I'm Amelia Dalton, host of Chalk Talk, and today I've got KJSPMM.V, I got carried away with the abbreviations there, Kai Johnstad, Senior Product Marketing Manager from Vicor, to help us solve all of our MIL standard COTS power problems. And before we get started, don't forget to click that link. There you can find out more information about military and defense products from Vicor. Hi, Kai. Thank you so much for joining me today.
Oh, my pleasure. Thank you.
So when we are designing for aerospace and defense, we face some unique engineering challenges in the area of power. But before we dive into that, give me a quick background on Vicor and defense. What do you guys know about this stuff?
Well, the Vicor has been in the defense and aerospace market for quite some time. Actually, it's been the better part of 3 decades. And one of the things that we pride ourselves on are keeping pace with the increasing demands for power supply needs in the defense marketplace, being smaller, lighter, and more power-dense products. In addition to that, one of the major components for power supplies in the defense and aerospace market is that we are designed and manufactured in the United States. All of our products are produced here in Andover, Massachusetts. Defense and aerospace products and applications are a very significant portion of our business, and we provide very good technical support, among other things, to our customers, and we provide solutions for our customers.
Okay, so you guys obviously know what you're talking about when supplying to this market. Let's look specifically at your power-related products. Give me a quick overview.
Well, Vicor, we produce a wide range of power supply products for the defense marketplace, whether it's AC to DC, DC to DC, filters, configurable products, configurable being multiple output power supplies. Our products provide best-in-class power density, which yields thermal and electrical benefits to our customer base, with stringent SWaP-C requirements. Now, SWaP-C is a term that's used extensively in the defense marketplace and refers to size, weight, power, and cost. And our products are uniquely suited to meet all of those requirements as imposed by defense contractors as well as end governments. Products are suited for a majority of the military environments, whether it's 28-volt input requirements, 270-volt input requirements, input filters for these products, which are a very big component of military applications, as well as harsh environments, etc. And we are compliant to a wide variety of military standards. MIL standards such as MIL Standard 461 for EMI, as well as MIL Standard 1275 or 704, which typically reference input transient requirements for defense applications. In addition, we have a wealth of online tools that really assist our customers in developing power supplies. The main one is Power System Designer, or PSD, and this is where customers can go online to create complete power supply solutions tailored to their specific needs and applications.
Okay, Kai, so what do you have in new power supply solutions? I hear you guys have just released something exciting in this realm?
Yes, and I'll be getting to that a little bit more in a minute, but just to kind of give you a high-level overview, it's the VIA DCM plus the MFM filter. Essentially, we're trying to simplify designs by providing customers a better brick. And what this new product does is provides brick-like modularity, make it easy for customers to use, and it provides 2.5 times the power density by volume and over 3 times the power density by weight than the next best competitive solution. It has more advanced integrated features, it's more thermally depth, which makes it easier for customers to be able to cool the product, and it purports Vicor's power component design methodology.
Okay, Kai, so you mentioned the power component design methodology. So before we move on, what exactly is that?
Well, Vicor has this power component design methodology, which is an optimized approach to power design. And it's essentially a modular system of building blocks that enable solutions achieving things as high density and efficiency, flexibility, scalability, a fast time to market, as well as being very cost effective. And these optimized modular building blocks provide either isolated or non-isolated solutions, AC input, DC input, regulated, non-regulated, high voltage, low voltage, essentially whatever a customer would need to configure a complete power supply.
Okay, so let's dive into some details here. What are the latest and greatest you've got in the world of power modules?
Well, the newest DC to DC solution that we have are the MGrade ECM VIA modules. These products are tailored for the defense marketplace by providing a minus 55 to 100 degrees C temperature operation, which is critical for defense applications. We have two primary families in this product line, the 3714, which for defense markets are 270 volt input modules with 24 and 28 volt outputs. The 5 and the 12 volt outputs will be coming soon. In the 3414 family, we have the 28 volt input modules, and we have 12, 24, and 28 volt outputs currently released, with the 5, 15, and 48 volt outputs coming soon. As you can see on this chart, we actually have a matrix of all the VIA DCM products that we currently offer. And the products listed in blue are the initial products that we'll be offering for MGrade applications, which again provide minus 55 to 100 degrees C operation. The MGrade DCM VIA modules deliver fully isolated, tightly regulated outputs up to 500 watts of output power. And these products also have integrated EMI filtering, as well as secondary reference control interface and flexible thermal interfaces.
Okay, and you've also got some new options in filters, is that right?
That's correct. Typically for most defense applications, customers not only need a DC to DC conversion solution, but they also need a filter module to be able to filter for things such as EMI, electromagnetic interference, as well as input transients, which can occur in a variety of systems. We have two new versions available. We have the 28 volt input and the 270 volt input MFM filter modules. The 270 volt input has the same input voltage range as the 270 volt VIA DCM products I spoke about earlier, 160 to 420 volts, and it provides compliance to mil standard 461 for EMI, as well as mil standard 704 for input transients. This product can provide up to 640 watts and is compatible with the 270 volt input VIA DCM modules. Also, we have the 28 volt input MFM module with a 16 to 50 volt range, which has the same input voltage range as the 28 volt 3414 MGrade DCM VIA modules I spoke about previously. This product provides mil standard 461 compliance for EMI, as well as mil standard 704 for input transients, as well as mil standard 1275 for input transients, which is a specification primarily for ground vehicles. This product can provide up to 350 watts of power, and one thing to note that the 28 volt input versions will need to be paired with the MGrade versions of the 28 volt DCM VIA in order to maintain mil standard 1275 transient protection. As an MGrade product, it provides operation down to minus 55 C, and it's in a very small size. We refer to this as our 1714 package, which is 1.76 by 1.4 by 0.36 inches.
Okay, Kai, so what if I have different packaging needs? Do you have other form factors available?
Yes, I've been speaking primarily about the DCM in a VIA package, but we also have the DCM in a chip package. These are isolated, regulated DC to DC converters in a package we refer to as converter housed in package or chip power component platform. It's a much smaller platform, doesn't have quite the same feature set as the DCM VIAs, but it is an extremely power dense DC to DC conversion solution. For the defense applications, we have three primary input voltage ranges of 28, 30, and 270 volt nominal inputs. We also have a variety of other inputs as well, 24, 48, 275, 290, and 300 volt inputs. These input voltage ranges are primarily for other applications, but they do occasionally find homes in defense applications. We have output voltages ranging from 3.3 to 48 volts, all regulated and isolated. And one thing to keep in mind is that only the MGrade versions can operate down to minus 55 degrees C. We have two package sizes. We have the 4623 chip, which measures 1.9 by 0.9 by 0.3 inches, and these chips are primarily for the higher input voltage ranges, anywhere from 120 to 420, 160 to 420, or 200 to 420. And then we have the smaller 3623 chip, which measures 1.5 by 0.9 by 0.3. And these are primarily for the lower input voltage range applications, primarily the 24, 28, 30, and 48 volt inputs.
So help me out, Kai. I need a little help choosing which one is best for my application. How do I figure this out?
Ultimately, it depends on what's most important for the customer. As you can see on this slide, I'm trying to compare and contrast our earlier products, our 300 volt input maxi, with an MFM3 filter, along with the products that I just mentioned, the 270 volt 3714, along with the 270 volt MFM filter. For applications that are looking for good power density, but with familiar, easy to use features, the 300 volt input maxi with the MFM3 may be a better solution. It uses our platform that's been around for well over 10 years, and it's familiar to a lot of our customers. For customers that are looking for a balance of high power density and feature-rich capabilities, taking it to the next level in terms of performance, the 270 volt 3714 with the 270 volt MFM may be a better solution. When you're comparing the two different solutions in terms of specifics, in terms of the input voltage and output voltage, the Maxi with the MFM3 has a slightly narrower input voltage range when compared to the 270 volt 3714. Both have the same power at 500 watts. There is a difference in full load efficiency. The 3714 with the 270 volt MFM has a much higher power density of 93.6% versus 88.5% for the Maxi with the MFM3. In terms of dimensions, there's really no comparison. 3714 with the 270 volt MFM is a substantially smaller product. The filter measuring 1.8 by 1.4 by 0.4, where the DC is 0.38 by 1.4 by 0.4 inches. And that compares much favorably to the Maxi with the MFM3, which the filter has dimensions of 2.3 by 2.2 by 0.5, the traditional half brick format, and where the DC to DC converter has a larger 4.6 by 2.2 by 0.5 inches, which is the traditional full brick. And this corresponds to a big disparity in terms of power density. 3714 with the 270 volt MFM has a power density of 159 watts per cubic inch versus 66 watts per cubic inch for the Maxi with the MFM3, while both products meet approximately the same mil standards in terms of mil standard 461 and mil standard 704 for input transients.
Okay, so it looks like it depends on if I need the absolute power density or if I'm balancing other factors.
That's correct. We do have a solution available, the 4623, in a chip platform, which provides customers the maximum power density and the lightest weight. So this product could be more suitable for those types of applications. For customers who want more of a balance of power density as well as more brick-like features, the 270 volt input 3714 with the 270 volt MFM may be a better solution. Both products provide the same input voltage range of 160 to 420 volts, same output voltage in this case at 28, same power level of 500 watts, as well as efficiency at 93.6%. The difference being that the 3714 with the 270 volt MFM has an integrated filter in the DCM as well as the external MFM filter, whereas in the 4623 does not have a prepackaged filter offered by Vicor, although we do provide guidance and assistance in customers creating their own filter. Now, the 4623, being just essentially a raw DC to DC conversion engine, has an extremely high power density of 1032 watts per cubic inch, which when compared to the 3714 DCM has a smaller 250 watts per cubic inch. And when integrated with the filter, the power density is a slightly lower 159 watts per cubic inch. The 3714 with the MFM does meet mil standard 461 and mil standard 704 for EMI and transients respectively, whereas the 4623 does not unless the customer adds an external filter, which again Vicor can provide guidance in creating. In terms of thermal management, the 4623 does require external heat sinking to be applied to the product, whereas the 3714 does have an integrated heat sink built into the product.
So everyone cares about SWaP-C, but different applications have different emphasis on size, weight, power, and so forth. How does my application drive my requirements in power?
Well, all applications are a little bit different. So solving the unique power challenges of SWaP-C, which I referred to earlier as size, weight, power, and cost, are a little bit different depending on the application in the defense space. On this slide, I reference 4 different applications, the first one being an airborne equipment challenge, for in this particular case, a scalable modular DCM-based design that enabled a high-powered regulated output. And a unique aspect of this application was the requirement to drive 200 millifarads of bulk capacitance. And this is something that we were able to accomplish with DCMs as well as a BCM or bus converter module that's a product also offered by Vicor. In the upper right, there's an application for a UAV, and the challenge for this application was to be able to provide a very power-dense, high input voltage solution that would enable power to be transmitted over a 25 to 30 meter tether to the UAV itself. And also being a UAV, weight was of the utmost concern. Lighter weight meant more payload for this particular application. In the lower left was an application for an avionic computer, and the enabling factor for this particular application was that we had a variety of low-profile components, less than 8 millimeters, as well as a high-temperature requirement to operation up to 125 degrees C. And then finally, in the lower right was an application for communication equipment. In this case, the DCM's fixed switching frequency of 750 kilohertz enabled the customer to be able to create a compact EMI filter to meet stringent conducted noise specifications.
I think I'm ready to get started. Where should I go for more information?
Well, on this slide, you can see a variety of resources that we have available. Most of these, or all of these, can be found on the Vicor website. We have the VIA DCM product family page where customers can go and find a wealth of information regarding the DCM product line. We also have a web page on our website to allow customers to get information about the MFM filter modules that I spoke about. Also on the website, we have a wide variety of application examples, including the 4 I just mentioned, the airborne equipment challenges, UAV challenges, avionic computer challenges, as well as communication equipment challenges, as well as other case studies available online so customers can take a look and get some more information into exactly how we solve those particular requirements. We have a defense and aerospace market landing page. And then finally, the Power System Designer that I spoke about earlier in the presentation, which is an online solution that allows customers to go through and configure tailored solutions to their specific needs and be able to do things such as simulations.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Kai.
My pleasure. Thank you very much for taking the time.
Before we go, you didn't forget to click that link, did you? There you can find out even more information about this broadcast from Vicor. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, check out the Chalk Talks section of eejournal.com or head on over to YouTube, keyword EEJournal.